Hello everyone. My name is Zhao Pengju, comes from China Mobile. I'm a developer. 2 years experience of object storage and 2 years experience of OpenStack. Now mainly focused on Manila, Kabul, and Sender. The other two of my colleagues are mainly focused on storage and network. Due to some special reasons, they cannot attend the OpenStack Summit here. So I will talk all the contents in this topic with you. In the past 2017, China Mobile has published this distributed shared file system service in the public cloud. It's based on Manila with GlusterFS backend and using NFS-Ganesha to export the NFS protocol. We provide a solution that can provide service for both virtual machines and bare-metal servers at the same time. In this topic, I will share all the technical details about it. At this topic is a beginner level. So firstly, I want to talk about Manila concepts overview. Secondly, I want to introduce the technical selection in China Mobile. Then I will introduce the architecture and Manila in China Mobile's public cloud. Last, I will talk about the implementation details, focus on what we have done and optimized in the process of testing NFS service in OpenStack cluster. I believe that all of you here are already familiar with Manila, so I will quickly go over the basic concepts of Manila. Manila is an OpenStack project to provide shared file systems as a service. It brings self-service shared file service to the cloud. It provides an open standard API for self-service management and provisioning of shared file systems and vendor-specific API for provisioning and attaching file system-based storage, such as NFS, CIFS, SafeFS, HDFS, and other network file systems. Manila mainly contains 3 modules: API, scheduler, and share. API provides a standard REST service for the GUI or client purpose. The scheduler provides a scheduling strategy, make professional decisions for share requests. The share services manage the process of the backend and communicate with the storage subsystems. After simply going over the basic concepts and the architecture of Manila, we will focus on the technology selection and what we have done with Manila in the remaining chapters. We started to study and test Manila since 2016. Before we release our private Manila version, we experienced several technical solutions: Surface VM, GlusterFS native driver, GlusterFS driver, GlusterFS deeply integrated with NFS-Ganesha, that we call it NAS driver. In the beginning, we tested the generic driver that we called it Surface VM. It means we use a virtual machine to provide NFS or CIFS service. This driver uses Nova instance to export the NFS or CIFS service, use sender volumes as the backend storage, and can use the existing NAS that are controlled by Neutron. The advantages of this solution are it can manage both control paths and data paths, and can reuse the OpenStack core modules, Nova, Neutron, and Sender. These 3 modules are very mature, but obviously it is unstable. Shared servers have single points of failure problems. No matter the community or us do not have a perfect solution to solve this problem. At the same time, extra community resource will be created. And as the shared service is configured in the virtual machines, this brings a lot of difficulty in operation and maintenance. So at last, we drop this generic driver. Then we tested the GlusterFS native driver and GlusterFS driver. Both of them are using GlusterFS as a storage backend and a serving file shares to the shared file system clients. In GlusterFS native driver, the share layout only supports GlusterFS volume, so the instance can only use GlusterFS protocol to access the shares. Access to each share is allowed access control via TLS certificates. The users must install GlusterFS client application. The most important thing is GlusterFS volumes are not created on demand. All the volumes should be created in deployment plan, and with some other issues that show in the community. So we drop this driver. In GlusterFS driver, both of NFS-Ganesha and GlusterFS NFS are supported. Shares can be accessed by NFS version 3 and version 4 protocols. The Gluster NFS has some controller issues, for example, the access rules, and can only be used through NFS version 3. The community version of GlusterFS and NFS-Ganesha integration is not product ready. The NFS-Ganesha portion is semi-finished. Without NFS-Ganesha HA cluster high availability cluster features. In this driver, the data path is not controlled by Manila GlusterFS shell driver. As the issues that I mentioned, we do not choose these two drivers. So we do some refactor, integration, and optimization with GlusterFS driver and NFS-Ganesha. And at last, from our own solution that we called it NAS driver. I will introduce how we implement it and the follow-ups in the follow-up sections. This is the architecture overview of our NFS service in the public cloud. We mainly divided this schema into two levels. Manila is control path, provide self-service shared file system service and manages the lifecycle and access rules of the shared file system. The data path provides a way to access the shared file system in a storage pool. The detailed technical framework is shown in this picture. That we use the GlusterFS and NFS-Ganesha integration solution. We mainly optimize the solution for providing NFS service based on Manila in three aspects. They are all in the two paths that I mentioned at last. Firstly, driver integration and control path HA solution. Secondly, data paths high available. Thirdly, network solutions for both KVM cluster and bare metal cluster. Based on the GlusterFS driver and Ganesha driver in Openstack community, we integrated them and do some custom development and optimization. The main process of the new driver that we call it NAS driver is in this picture. GlusterFS volume maintains the shell file systems, its directory layout. NFS-Ganesha does the export operation for shell file system, and the export configurations for shell file systems are stored in the GlusterFS shared volume, which is named Gluster Shared Storage. It's the inner volume of GlusterFS. This can keep the configuration files consistency of different NFS-Ganesha servers. In our test, we found that after rebooting the servers that we mounted the Gluster shared storage, the mounting relationship of Gluster shared storage will lose. This is an issue to keep the configuration files usability. So we extend the GlusterFS shared storage service to support the automatically mount on boot. In integrating with NFS-Ganesha, GlusterFS itself had some problems. First, what's the problems of the current upstream GlusterFS driver when integrated with NFS-Ganesha? First, it cannot really do the export only create a directory. GlusterFS command inspections in a concurrency scenario. What's the shortage of the current upstream GlusterFS driver in fulfilling our needs? It do not have a mapping between backend storage states and Manila shares. The optimization of GlusterFS driver mainly focuses on these three aspects. As we use NFS-Ganesha, so it is recommended to add the process of doing NFS export through NFS-Ganesha in GlusterFS after limits the directory usage. Add the distributed synchronization lock in some operations of GlusterFS with using command, for example, cluster quota, and so on. Add monitor for the backend storage to acquire the backend status and system information, so that we can keep a mapping between backend states and Manila logical shares. As we integrated NFS-Ganesha, so we use NFS-Ganesha to control the access rule. So the issues that on GlusterFS offer access control will not appear in our NAS driver. The problems of the current version of NFS-Ganesha driver is mainly these three aspects. Firstly, poor performance to do the export action in a concurrency scenario. Using multiple remote, it is because it is using multiple remote login with SH, using SQLite to store the export ID information. Secondly, configuration file consistency of NFS-Ganesha are not a concern. The NFS-Ganesha configuration files which are used to persistent the export config are not concerned. Resource management of NFS-Ganesha export ID. First, it is unable to guarantee the uniqueness of export ID. When some create request comes concurrently, the export ID may be same. Do not concern the security of export ID, which is up to 65535. It do not retrieve the export ID after the export being removed. For every IP addresses, one export ID will be consumed. In order to solve the problems that I mentioned, we use the following methods to update the mechanism of export ID. Use MySQL cluster to store the export ID to solve the problem of poor performance and the uniqueness in concurrent scenarios when using SQLite. As you know, Ganesha now use SQLite to store the export ID usage if you do not use Redis. When we want to assign an export ID for shared export, we should first log into the remote Ganesha server and then execute SQLite commands. This is very inefficient and unreliable. In our test, when there are 100 concurrent create requests to come, only 30 requests may be successful. So we store the export ID in MySQL along with some Manila database tables. Although this may be architecturally coupled with the backend storage, it is still much simpler and effective than taking the approach in the community. Retrieve the export ID after export being removed, so we can reuse the export ID which is not used anymore. In the native program of the community, it can get a new export ID if we add a new export, but the export ID will never be retrieved. As you know, the export ID of every Ganesha service is up to 65535. So the recycling of the export ID is very necessary. Third, use update export instead of add export for every IP addresses. to save the usage of export ID resources, but it has a limitation. NFS-Ganesha version should be 2.4 or higher. The native program of the community will add a new export for every IP address. For example, if the users add 3 IP addresses to the access rules, 3 export ID will be consumed, and 3 configuration files will be generated. When using updated export, all these 3 IP addresses can be configured in a single configuration file, and only 1 export ID will be consumed. Because Ganesha driver uses SSH to log to the Ganesha server and write the configuration files. This may cause probabilistic failure. And then the temp configuration files will stay in the configuration directory and will never be removed. We solve it and contribute it to the upstream Manila branch. Most of us use this deployment architecture to ensure that the shared service is high availability for backend management. At the same time, we usually configure the 2 Manila shared service with the same host in Manila configuration file to achieve high availability of shared services. Is this enough? In our test, when one of the shared services is down, we may lose the control of the shares that created by the down services. So we add a health checker in Manila to make the backup share service take over the shares which are in the uncontrollable state. We add a child module named health checker in Manila scheduler. Although this is not quite in line with the original design of the scheduler, we think it's much better than providing a separate module. The health checker is functionally independent with the system scheduling, although they use the same module. In this architecture, health checker, which is the leader, always monitors the Manila shared services status. When one of the shared services was down or be removed, the health checker will do a migration of the controller relations. The shares that want to uncontrollable state will be immediately taken over by the other serving shared services. This can make sure all the shares are always under control, makes the shared services be truly high available. NFS-Ganesha itself has single point of failure problems, so we use CTDB to solve it. As we use cluster shared storage to store the Ganesha configuration files, it is easy to maintain the consistency of the export status of different NFS-Ganesha services. Based on this premise, we integrate NFS-Ganesha and CTDB to make multiple single NFS-Ganesha service as NFS-Ganesha cluster. CTDB monitors the operating status of all members of NFS-Ganesha cluster. Once an NFS-Ganesha member is detected abnormal, immediately move it out of the cluster and transfer the service IP to any NFS-Ganesha member that is running well. This ensures the continuity of the client to the NAS character business and the reliability of the data path. GlusterFS itself is a distributed design storage system, do not have single point of failure issues. This is the way we use GlusterFS in our actual production environment. For example, the public cloud. Each server has 20 SATA disks. We do read 5 for each 5 disks. This can reduce the number of cluster bricks to reach a higher performance and provide 2 levels of data reliability. No matter one of the disks or one of the bricks, or one of the cluster storage server down, the cluster can be accessed normally. As we use IP addresses for access control and resource isolation, so the core of the network needs is to make the virtual machine and bare metal servers to be network connected in L3 layer. We use SDN solution to satisfy our network need. In SDN gateway, add rules of NAS to guarantee the network connectivity in L3 layer. Add some ACLs to the VRF, permit or allow 137, 138, 139, 445, and 2049 port, permit NFS, CIFS, and the SMB protocol. Deny the telnet, SSH, FTP, and ICP operations. In this solution, if the virtual machine want to access the NAS storage, users should add an extra port from NASnet, which was pre-designed during the construction of the data center. For bare metal servers, as the NICs are limited by the physical network cards, so we added a new child interface to all the bare metal servers. If the bare metal users want to use NAS, he can use it directly. Building and monitoring are essential parts in public cloud. The needs for us are as follows. First, we want a way to get all the shared states that are created by the OpenStack projects, including share size, used size, and so on. We need a way to get all the backend storage info for monitoring. But the issues are, the backend does not maintain the mappings between shared surfaces and projects. So if we get the monitored data directly from the backend, there is no way. So we must do this in Manila. Manila only maintains the backend storage information in the memory, which is reported by the Manila share to Manila scheduler. And no APIs for the clients to get them. So we add a states query and a maintenance mechanism in Manila. We use Manila share to do the periodic inquiry of the share states info, which using command cluster volume quota list, and so on. Manila share will report the share states and the storage info to Manila scheduler periodically. After that, the monitor and the states platform can query the data through API. And the API will send RPC call to Manila scheduler to gather states info. Here we use periodic inquiry, but not use the API module to backends or point-to-point query. The reason is that when executing cluster volume quota command concurrently, some of the execution will fail. This is the issue on GlusterFS query. It has a poor performance. We cannot solve it in a short time on GlusterFS, so using periodic tasks may solve the point-to-point issue. In the latest release, we integrated GlusterFS and Samba to support CIFS protocol for end users, so that they can use the shared file system through Windows and Linux. Also, some new versions of Windows support NFS protocol. This process of exporting CIFS protocol is like with the process of NFS that are using Ganesha. GlusterFS maintains shared file systems, and the Samba driver do the export operation for shared file system with using command like netconf. 2 points should be concerned. First, high available of SMB servers. We also integrated SMB and CTDB to make sure SMB servers are high available. Secondly, the access control. After doing the SMB export, we should firstly set the access rules with localhost. If not do this, all the clients have permissions to access the share export. Some screenshots of Samba driver. The Samba driver will online in June. By the way, we hope to push the Samba driver to the community. Our main version of OpenStack is Kilo, but the Manila branch that we use is Newton. How we install them in a cluster? As you know, Manila is a relatively independent module, and we do not use Manila network. So in the functionality, Manila do not have dependency on other OpenStack modules. In order to solve the software package version conflict and install the Manila services together with other modules to save controller server resource, we use Docker to install Manila. That's all. Anyone has some questions?
Yes, I have a question. How long did it take from you the stage your design and start to implement the system till you really worked with it? How time it took?
How
long
we designed it?
From the design stage till it got into production?
Since 2016.
Again, please?
2016.
2016.
Nearly 1 year. Nearly 1 year.
So hi, I'm Tom Barron. I'm
hi.
the
I know you.
PTL for the Manila project.
Yeah.
This is awesome work. You're doing all kinds of great innovation, tackling a lot of problems that we're also looking at in the upstream community. We don't have anybody working on Manila, on GlusterFS.
Yeah.
We haven't for probably about 2 or 3 years. We would love it if this energy and innovation could be channeled upstream. We would love to work with you. We would love to help solve these problems together. Do you have any plans to work with the upstream community or just to maintain this as a separate fork?
Yeah. Our company, sorry.
That's right.
Most of us focus on the development of community. Also, we just do it in our own version. We like to push it to the upstream version.
You would like to?
Yeah. We like to do that.
So is there anything inhibiting that? Is there anything stopping you from doing that? Is there something we can do to help make it more possible for you to do that? Because right now we have nobody working on Gluster. We have a lot of creative work. My passion is to get, in Manila we have a bunch of proprietary backends that are very established that work well. My passion is to get open source end-to-end solutions that work at production, at scale. You're developing a public cloud. You're working it at scale. It's exactly the kind of thing that we need going on. My own energies on that are more with the CFFS backend and with the CFFS plus GlusterFS backend. There's a common problem space on a lot of the GlusterFS stuff. We've done recent stuff with GlusterFS that you might be interested in. I mean, I'm sorry, I said GlusterFS. Ganesha, CFFS plus Ganesha. Okay, so there's a common problem space on the Ganesha aspect of this, as well as some of the stuff you're talking about in the scheduler and so on. There's really a lot of opportunity for collaboration if you're interested in that. Is this code on GitHub or anything, or is it entirely private currently?
Maybe I I did not understand what's your question.
My question is this open source code that you have, even if it's not part of the upstream Manila project? You've forked the project. You've done all kinds of great stuff. Is this code something you have intellectual property on? Is it something that is unpublished, or is it published and available and other people can use it?
No, we just...
We can publish all of mine to the community.
Pardon? I'm sorry.
We can publish our code to the
You can. Yeah, and would you also be interested in working on with the community upstream and contributing there?
I think it's okay because we have GlusterFS team and a SEF team. We can put our two teams to give contribution to the Manila project.
Yeah, we would love that. I mean, it sounds like you're doing awesome stuff. I think we may have some things to contribute for you as well. You know.
No problem.
Okay, all right, awesome, thank you.
But I wanted to say that the issue is some design of the Manila schedule may be not in line with the original design in the community.
I think you did a great job of showing a lot of the shortcomings. I mean, I might not agree with you on every little point or something, but a great job of showing areas that need to be addressed and need to be worked on. You might need to do something different than the upstream community. I understand that. You also might have ideas that if you brought them to the upstream community, everybody else would say, oh, why were we doing it this way? We should do it the way they're doing it.
Okay.
I would love us to have that conversation. I'm not promising that everything that you have as an idea is something that the upstream community will adopt. That's not true for anybody that participates in it, right? Where we have give and take, and we go do our own thing, or we figure out ways that you can set configuration options. So some people can do it this way, some people can do it that way. It is work being involved with the community, but there are rewards in it as well. You know, I guess is what I can say. You know, I strongly believe in those rewards. That's why we're doing it rather than just developing something for ourselves and selling it.
Okay, thank you. Anyone else? If not, this topic will be finished. Thank you.